like number 50, okay? And so number 50 says we have two train whistles, A and B. Each have a frequency of 392 hertz. A is stationary and B is moving to the right away from A at a speed of 35 meters per second. And we have listeners in between the two whistles, and I'm going to have them move to the left at 15 meters per second. And what is the frequency from A that's heard by the listener? And then what is the frequency from B that's heard by the listener? And what's the beat frequency detected by the listener? Okay, so we have a little picture, and I like this formula. I like it best because it needs pictures. And in case y'all haven't figured out, I like the diagrams. So there's my stationary train. So then the velocity of A is 0. Okay. And then here's train B. They look a lot like cars, by the way. And then B is going to head to the right at 35 meters per second. And then I'm going to have my little listener. That's the person. And they're going to go left at 15. We'll do L for listener. And so each of the trains have the same frequency. And so the frequency is 392 hertz. And so the frequency of A is the frequency of B is 392 hertz. So this is what you hear if the trains and you are both stationary. Okay. And so then the question is, the listener, what frequency do they hear from train A, and what frequency do they hear from train B, and then what's the beat frequency between the two? I guess there was an accident because like the legs aren't attached to the body anymore. I'll try to fix that. There we go. Except for now they've got extra legs or something. I don't know. I think I might still have some not be caught back up on my sleep yet. So, all right, there we go. There's our person. Legs attached to the body. Looks good. All right, so then what I'm going to do is I'm going to draw the sound as it goes from the train A towards the listener. So this is the way that the sound travels. And so if the velocity of the listener and the velocity of the source is the same as the velocity of that sound, then it's going to be positive. So since these go in opposite directions, then this velocity for the listener will be negative in the formula. Okay. And so then let's calculate what frequency this listener hears from train A. So this will be our frequency heard by the listener for train A is the velocity of the speed of sound in the air, which is our 344, minus the velocity of the listener. Now, since these go in opposite directions, that's going to be negative. So this will be negative 15. And then this is our 344. And then train A is not moving, so this is 0. And then the frequency was our 392 hertz. And so what frequency does the listener hear? So as they're heading towards the train A, they should hear a higher frequency. So this should shift up. So it's a minus, and let's watch our signs. So this will give us a plus. $409. All right. And now let's figure out what frequency our listener's going to hear, but from train B. Okay. And so I have to draw in that the sound waves from B towards the listener are going to go like this. Again, that's our 344. But now notice that the sound wave and the listener travel the same direction. So this will be a positive 15 on this formula, but that the train B going this way, but the sound going that way, this is an opposite direction. So that'll be a negative 35 in this calculation. So we'll put in our 344 minus, and so since these both go the same way, this will be positive 15. 344. Now, since these go opposite, that'll be a negative 35. And then multiply by our 392. So again, the minus gives us a plus, and then don't miss this minus sign here. So these are going to combat one another. Well, actually, they're going to both combine the same way, right? Because this makes a bigger denominator. This makes a smaller numerator. This makes something less than the 392. So 340.3. And so then we can calculate what kind of beat frequencies we would hear. And probably because I messed things up, I changed the problem. So we just take the difference between these, 409.1 minus 340.3. And so what beat frequency do we hear? 68.8. There we go. And usually they got to actually be pretty close. So this might be too far away to be the beat, but that's okay. That's what it would be. All right. Questions? This is how we use the formula. And I really like that it comes from the picture. It gives you the signs on the V's, and then it just pops out.